Okay, class, hello. I'm not going to be here today, so here's what we're going to do is you're going to listen to, we're just going to go through the first page of these notes, and then on Tuesday we'll go through the second half, okay? And then after these notes, you'll do a little maze activity. That will be for homework due Tuesday. Okay, so here's what we're going to be starting with. This is going to be Unit A, which is Unit A is basically where we have like certain Pythagorean theorem, where we're using trigonometry. I'm going to start you guys off with something you already should know, but we're just going to review it just in case you need a little refresher, okay? So here's what we're going to talk about. You are going to be able to simplify radical, and then tomorrow or on Tuesday we'll learn about Pythagorean theorem, okay? Okay, so here's what we're going to start off with. It says perfect squares, and it says list the first 15 perfect squares. What I'm talking about is this, okay, is starting off with 1. What I'm thinking about is like, what's 1 times 1? It's just 1, okay? I'm going to keep going up all the way to 15. So that next number would be 2 times 2, which is 4, okay? The third number would be 3 times 3, 9, okay? Fourth number would be 4 times 4, 16. Next would be 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. 10 times 10, 100. Okay. 11 times 11, 121. Okay. 12 times 12, 144. Okay. 13 times 13, 169. 14 times 14, 196. And then finally, 15 times 15 is 225, okay? These are the perfect squares that come from multiplying itself by itself, okay? I'm going to say this. You probably have to memorize them, or you need to know how to find them because we're going to use them, okay? Okay, so we're going to start off easy. It says simplify the perfect square roots below, okay? So what you're doing is, like, if you're looking at that number, okay, like let's say we have a number in here, you're thinking what two numbers are going to multiply to give me the number inside the root, okay? So let's start with an easy one. The square root of 16, it's what times what will give me 16? It's going to be 4 times 4, so the square root of 16 is just 4, okay? We're going to use a little bit harder one. So now it has 2 times square root of 121. Here's what I'm going to start with. Square root of 121 is what times what? That's going to be 11. So that comes outside the root once I do that. And then I have that 2 out front, so I'm going to multiply 2 by 11, which would be, final answer, 22. Okay? For number 3, you're going to do the square root of 225 first, which is going to be 15. 15 times 15 is 225. And then you're going to multiply that by 6. And so 6 by 15 would be 90. Okay. For number 4, square root of 81 is going to be 9. Bring that 3 down. 3 times 9, 27. Okay. And so we're just getting that down to a single number. Okay. But unfortunately, that would be in the case we had a perfect square root every single time underneath that root, okay? So what we're going to do now is we're going to think about what happens if we don't have like a perfect square root, meaning one of these numbers from above, to help us simplify those roots, okay? So here's what the second section is going to be on, okay? You're going to be simplifying non-perfect square roots, okay? Here's what you're going to start with, okay? Using the numbers above, you're going to find the largest perfect square that radical is divisible by, meaning it divides evenly into a whole number, okay? And you're going to break that down using that number, okay? Once you do that, you should have a perfect square. You're going to take the perfect square just like you've done before and take it out of the radical just like we did before, okay? What's going to end up happening is you're going to have these leftovers. You're going to leave those leftovers underneath the radical symbol, okay? Which means you're going to have this in your answer, okay? So let's just practice using a couple of these. Just a reminder, I know you can't see them, but I'm thinking like I'm using one of these, okay? So I'm going to think like what is divisible, okay? So here's where I'm going to start. Square root of 32 is not a perfect square root, okay? What I'm going to think about is what number goes into 32. I'm going to start off not with 1, but I'm going to start off with 4, okay? So starting off with 4. 4 does go into 32 8 times, but let's see if there's any number that's higher, okay? So the next number would be 9. 9 does not go into 32, so we skip over that. The next number after that would be 16. 16 does go into 32 twice. So what I'm going to have is this breaks down into 2 parts. It's going to be the square root of 16 times the square root of 2. Okay, so it breaks down like that. Once I do that, I should have a perfect square in my answer. So the square root of 16 is just 4. Okay, your leftovers are going to be that square root of 2. You're going to leave underneath like that. Okay. And once you got it fully simplified, because you can't simplify the square root of 2 any further, you're done. Okay? Okay. All right. Number 6, we're going to do the same thing. I'm not going to worry about the 2 right now. I'm going to worry about that square root of 54. Okay? So starting off with the square root of 54, you need to think about what number goes into 54. Starting with 4. 4 does not go into 54 because it comes out as a decimal. The next number, 9. 9 does go into 54. It goes in 6 times. Okay, so I break that down to 9 and 6. Okay, I still have that 2 up front, so you can put it there. Okay, but now here's what I have, is I have the 2 up front. I know the square root of 9 is 3, so that comes outside the radical. And then 6 is not a perfect square root, so I leave it over in the radical. What I can do then is these 2 numbers now outside the radical can be multiplied together. So you get 6 square root of 6. And that's your answer. Okay. Okay, let's try one more like this, and then we'll talk about rationalizing. Okay. All right, so for number 7, okay, you're looking at 28 square root. You're thinking about what number goes into 28, starting with 4. 4 goes into 28. It does 7 times. So this breaks down square root of 4, square root of 7, and you still have that negative 3 out front. Okay. So then from there, you're taking the square root of 4, which is just 2, and multiplying it by a negative 3. Okay. And so what you would have is negative 3 times 2 is negative 6, and you're left over with the square root of 7. This would be fully simplified. Okay. So that's what we're doing. Okay. Okay, so the next one, okay, last section is going to be talking about rationalizing the denominator. This is going to come into play more tomorrow, but I just want to start it today, okay? So I'm going to start this part because that's the important part, okay? I'm going to do it in a different color, okay? So it says to rationalize the denominator, what you're going to do is you're going to multiply both the numerator and the denominator by the radical of the denominator, then simplify. Here's what you don't want, okay, is the reason we do this is because we don't want a radical left in the denominator. So if I have like 1 over root 7, you don't want that root in the denominator, okay? That's why we're doing this. All right, so let's look at an example where we have this, okay? So you can see that there's that radical in the denominator, which means I have to get rid of it, okay? Here's what I'm going to do. That radical in the denominator, I'm going to multiply, I'm going to create a new fraction, both top and bottom, by that radical, okay, like so. Okay, and so what I would have on top is that 4 is outside the root and the 7 is inside. You keep them separately. So you'd be 4 square root of 7, okay, over, here's what I'm going to do. Since both the 7s are in the radical, you can multiply them together to get 49. Okay. You still have that square root sign because it doesn't just go away. But now, looking at that, the square root of 49 is just 7. So on top, you have 4 square root of 7 over 7. That's your answer. Okay, so essentially you just drop the radical in the denominator when you multiply top and bottom. Okay? All right. 2 more and then we'll be done. Okay? So for number 9, okay, here's what I'm going to say. It says that overall radical is over 81 over 2. You can break that down. So it's really the square root of 81 over the square root of 2. Okay? The square root of 81, we know, it's just 9. And then you still have that square root of 2 on the bottom. Okay? So because of that, we need to rationalize the denominator. Okay, so how do I do that? Well, I take my fraction and I multiply top and bottom by whatever that radical is. So it'd be the square root of 2 over the square root of 2. Okay. And so what I would have is I would have 9 square root of 2 on top. Now, you can do a couple steps in one. 2 times 2 is 4, and then the square root of 4 is just 2. So the radicals drop, and that's your answer. That's all you got to do. Okay. All right, number 10, okay, I'm going to say this. Make it simpler on yourself. You're just looking for the radical of the denominator, which is here, okay? That's what you have to multiply top and bottom by, nothing else, okay? So the square root of 6 over the square root of 6, multiply top and bottom. Here's what you're going to do. That 2 is not in the radical, so you leave it alone, but then 3 and 6 are both inside. That's just 18, 3 times 6, you're multiplying, okay? Then on the bottom, you have 5. 6 times 6 is 36. Square root of 36 is just 6. Okay, so it comes outside the radical. Okay, we can simplify further, so now it's just a game of numbers, okay? You're going to have 2 square root of 18, and then 5 times 6 is 30, okay? But now, let's tie it back to what we did before. It needs to be fully simplified. 18. You need to think about 2 numbers that go into 18, in which one is a perfect square root. So let's start with 4. 4 does not go into 18. The next number would be 9. 9 goes into 18 twice. Okay? So in other words, what you're going to have on top is this. You're going to have that 2 out front. You're going to have the square root of 9. And then left over is the square root of 2. And then on the bottom, you're going to have 30. Okay? And we're just simplifying from there. Okay? So square root of 9 is just 3. And so I'm really multiplying 2 by 3, and you are left with square root of 2. Okay. So again, 2 times 3 is 6, square root of 2 over 30. Okay. And so final last thing, 6 and 30, they can go into each other. 6 goes into 6 once, 6 goes into 35 times. So in other words, your final answer could be 1 square root of 2 over 5, and that's fully simplified because you can't simplify square root of 2, and 1 and 5 are fully simplified. Okay, so that would be your answer. Okay, cool. Okay, so that's it for the notes. Okay, I just wanted to show you guys for the homework what you're exactly doing. Okay, so let me just quickly go to that here. Okay. Okay, so for the homework, oh, I forgot. I need to go. Give me a second, guys. Okay. So the homework's going to be that maze activity, okay? What you're going to do is this. Give me a second. Okay. Okay. So for the maze activity, what you're doing is this is your starting point right here where it says start, okay? Whatever your answer is of that fully simplified is the path you go along, okay? So if like your answer is like 4 square root of 15, then your next problem would be 6 square root of 60. And then you just go along the pattern. Make sure you like either shade or draw on the pattern, and then you should end at the very end, okay? So that is the homework. I'm going to give you guys the rest of the time to work on it. I will be back Tuesday for any questions, but you guys can sign off if you would like.